Alright, so I'm going to do a couple problems at once here about critical values. Alright, so when you're doing a critical value check, you don't need this second sentence at all. It has no bearing on the problem, right? All we need to know is that we have an alpha 0.01 and then we have a mu greater than as our test. Right, that tells us that it's one-tailed, right? And then this tells us how much area is in the tail. Right, so we know that it's greater than, so it's area on the right hand. So basically the picture that describes this is we have a tail over here on the right with an area of 0.01, and all we're asking is what is that z-score or t-score that goes with that. Alright, so we're looking for area in one tail is 0.01, and we can see here we're doing a claim on a mean. So we have to do a t-score, and we don't know anything about. We actually kind of do need to know that that's an S and not sigma. If that was sigma, we'd be dealing with a z. Since it's S, we're dealing with a t distribution. So let me pull up the t distribution. So if you see, we have a t, and so remember degrees of freedom, where we actually will need that 9 as well, the 9 scores. Degrees of freedom is one less, so we go to the row for 8. And as we said, we have an area in one tail of 0.01. So we go to the intersection of row 8 and this column for area in one tail of 0.01, and we get 2.896. Right, and so the reason we know then that it's 2.896 and not negative 2.896 is just because we're talking about a greater than scenario, right? The greater than, this has to be on this side positive 2.896. If it was a less than scenario, we'd be over here at negative 2.896, right? So that's why that one is D. Now number 43, we're going to test the claim that the mean score is equal to, so that's going to be a two-tailed, right? When they don't say anything about greater than or less than, then it's a not equal. So this is a two-tailed test. Right, so now for this time, we have 0.01 significance again, but this time half of the 0.01 is over here, right, and half the 0.01 is over here, right, and so they want to know what are those two scores. Alright, so now this time there's two scores that give us that area, so we do need a plus or minus. Notice how these two have plus or minuses and these two right here do not. These can't be right answers because critical values for a two-tailed test are always plus minus. So now we need to go to back to the t-table, and we're going to go to, we have 20 randomly selected, so our degrees of freedom is going to be 19, and the area in one tail is 0.005, or the area in two tails is 0.01. Let me pull that up. So now I have the table again, and I cut out all the rows just so I didn't have to put the whole stinking thing on here. So the area in one of my tails is 0.005, or the area in two tails is 0.01 this time. And so we go to that column, and then we go down, like I said, to degrees of freedom is one less than the sample size, which is 20. So we go to row 19, and we get 2.861 is that number. Notice D is just, in case you forgot to do n minus 1, you'd go down and you'd find that answer, but D is wrong as well. So that means so that's not it. So 2.861 is the right number, so therefore it is B. So it's 2.861 because the table says so, and then it's plus minus because it's two-tailed.